What? That is the weirdest question. Where did that come from?
No, because this pencil that her mom bought in Denmark says, I feel Slovenia. So
See, what does it say?
I feel Slovenia. I don't know. I don't
Circle. Circle actually. Who is that? What's going on?
Do the move so yeah, do it.
Wait. Maybe don't do that.
I'm too old for whatever that is. But you all obviously know. Right, okay. Okay. Sometimes it's like we speak a whole different language. Okay, right. Record and trust. Share screen. Okay.
Where's the OG? Oh, yeah. Yeah, it's not. Try to check on YouTube.
I'm recording already. I don't know why I started recording. Okay. Maths paper 1, eh? No? Yes, no. 2021. Okay,
What the hell is this?
Right, let's have a look at this question quickly, guys. Okay, so usually you get a question, so what's the key things? Okay, so this is a calculus maximum and minimum question, right? And with calculus maximum and minimum, okay, they often come right after the calculus graph question in section B. Okay, so chances are you are going to get a calculus max, whether you're asked to maximize or minimize something.
Oh, yeah.
Okay, what's the process then? Whatever they ask you to maximize or minimize, okay, you have to get an expression for that in terms of, so an expression for what you ask to maximize or minimize in terms of one variable only. Because we can't differentiate in terms of two variables. To do the above, okay, you may have to use do some kind of substitution. Substitution. Okay. So whenever you ask to maximize or minimize, you want to get that in terms of one letter only. Okay. So to do that, okay, because you can't have, if you ask to maximize whatever volume, you can't have an expression for volume with x's and y's in or whatever, right? So they must give you some other information, okay, which let you sub in, so that you only end up with whatever you're trying to maximize in terms of one letter only. Once you've got that equation, think of graphs. If you've got a graph of x against volume, okay, where will maximums and minimums occur? Where the gradient is equal to 0. Okay, so max or minimums occur when the gradient is equal to 0. So if it was a case like this, it would be where the derivative of volume in terms of x is equal to 0. Okay, it's where the derivative is equal to 0. It's the same principle as a graph, guys. Okay, and then you're going to solve for x, usually, and sub back in to get whatever you're trying to maximize. Does that make sense? Okay, often they break up the question, okay, so that they give you the equation, and if it's early on in the paper, okay, in other words, they give you a formula else will be the same, show that the area is equal to that, so that you can use it for the next one. Okay, so let's quickly do this one over here. So it says here, a farmer draws a rough sketch, okay, of two adjacent fields. Okay, they're all, field A is a square, so fill in what you can. So what's this distance here? X, 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 right? Okay, field B is rectangular in shape with a width of Y, but that must be X as well, right? Okay. Area of field A plus area of field B, so field A plus field B is equal to 1,000 units squared. NR is the only fence that is shared by both field A and field B. So that is the shared fence between the two things. Okay. Find Y in terms of X. Okay. So how could we do that? Well, the area of A plus the area of B is equal to 1,000, right? So so this is for question A. So what's the area of A going to be? Okay, so the area of A is x squared, right? What's the area of B? xy, do you agree? X times y, area of a rectangle is the n times squared. So x squared plus xy is equal to 1,000, right? And what are they saying to you? Find y in terms of x. So we've got to isolate y. So we're going to get xy is equal to 1,000 minus x squared. Okay? So what's y equal to? 1,000 minus x squared over x. Are we happy with it? Finish? Okay. Right. Then it says, calculate the value of x. Everyone okay with that up to there? Okay. So that the minimum amount of fencing, okay, is used. Okay. So that the minimum amount of fencing is used. Okay. Right. But they didn't actually ask us what the minimum amount of fencing is, right? Okay, let's just have a look. Okay. So I've got to get, first of all, the amount of fencing that's used. Am I right? Okay. Because I'm trying to maximize and minimize fencing. So what's the process? I need an equation for the amount of fencing in terms of just one variable x. Right. So how much fencing? Fencing is what? Is the whole thing fenced, I presume? Okay. Farmer draws a sketch of two adjacent fields he needs to fence. Okay, so this is all the fencing, right? Okay, in red. That's all the fencing he needs. Do you agree? He wants to fence that, and he wants to put a fence there. They're just saying that that's a common fence. Capish? Okay, so now I need to do what, guys? I need to get a formula for fencing, right? How much fencing he needs. So, what's the fencing going to be? So this is the question B. How much fencing? So let's start over here. He needs, first of all, that egg distance x, right? So the fencing is going to be x plus, so the ant's walking around the fence, right? X, how much to get to there? Another x, right? Do you agree? To get to there? Y, right? To get down to here? That little bit? And this little bit? Do you agree that that's the amount of fencing that the farmer's going to need? So, did I include this bit? No, I didn't. I left out that. Okay, plus another x. Okay, so let's just check. X plus y plus x plus y plus x plus another x. Okay, add up the like terms. While I have a piece of chicken. Happy with that. Now, what are we trying to do? We're trying to maximum amount, minimize the amount of fencing, right? The problem is what at the moment? Now, to find the minimum, what you're going to do, where the derivative is 0. But you can only differentiate in terms of one variable. Of an equation for fencing in terms of two variables. So, they've helped us with the previous question, right?
Yes.
So I need fencing, whatever you're trying to maximize in terms of one variable. That's what I said in the method. You've got to often substitute in, right? To get fencing in terms of one variable. Right? So fencing is equal to 5x plus 2y. But we know that y is equal to that, right? We worked out that y is equal to 1,000 minus x squared over x. So I'm going to sub 1 into 2, right? Because what's that going to do? That's going to give me an equation. Sub 1 into 2 for what I'm going to maximize or minimize in terms of one variable only. The fish? Okay. We're good? So fencing is going to be what? 5x plus 2, but y is 1,000 minus x squared over x, right? Okay. We good? Okay. So, we're going to have to now differentiate that. Before we differentiate, I can't have variables in the denominator, right? Remember, there's a single term. If you're differentiating and you have something like this, they say find the derivative. If you've got two terms at the bottom, what do I have to do to differentiate? Factorize, cancel, and then differentiate, right? So that would be the derivative of x minus 2, x plus 2 over x minus 2. They would cancel, and I get the derivative of x plus 2, which is 1. If there's a single term at the bottom, I use this logic, remember? If 7 plus, what's 7 plus 21 over 7? Well, you can go 28 over 7, which is 4, right? Or you could say 7 over 7 plus 21 over 7, which will give you the same answer, 1 plus 3 is 4, right? So what are we going to do with this? We're going to split it up, right? Because it's a single term. When there's a single term at the bottom, we split it up and divide up. So how do that? So what are we going to get? Plus 2 times 1,000 over x, right? Minus, you can skip our steps, minus x squared over x. Because anything that over 7 means the whole thing divided by 7. You good with that? But now what don't I want? I don't want a variable in the denominator. So try to sort out that mess over here. So what's 1,000 over x going to become? 1,000 x to the? Okay, so this is quite tricky. Okay, minus x squared over x is? We're good with that? Distribute that 2 now and add like terms. So I get f of f is equal to 5x minus 2x, do you agree? Plus 2,000 so f is what? Remember, this is our second last question, guys. Okay, 3x plus 2,000. You've got a lot of marks to get up to here already. Okay. So have I got what I want now? What was the question? Maximize or minimize fencing, right? Whatever it was. So what was the objective? Okay, what was the process? You've got to get a formula for what you're trying to maximize or minimize in terms of one letter only. To do that, often you have to do it and substitute something in like we did, right? Then I differentiate what I need. I need all the variables to be in the numerator. Okay? Now, I can go to the maximizing part. And I can say, the maximum occurs when? Or minimum, right? The minimum will occur when the derivative of f, basically when the gradient is 0, right? So if you have a curve of x against f, okay, a minimum will occur, well, I don't know what the graph looks like. The minimum is going to occur when the gradient is 0 of the x f function. Okay, so what's the derivative of 3x? 3. What's the derivative of 2,000 x to the negative 1? Times that, remember? Negative 2,000 x to the negative 2. And I want to know where that is 0, right? Solving an equation, I don't want a negative exponent when I'm solving an equation. So how can I get over that problem? Rewrite this how? 2,000 over x squared, right? Let's move back to the other side. Oh, we don't have to. Okay. We can multiply everything by what? X squared, right? When I do that, I should really write that, but because x can't be naught, but it's not going to be. Okay, so multiply everything by x squared. You agree? So normally we say x is plus or minus, but what does x represent? Fencing, right? Can't have go by negative amount of fencing. Okay? So therefore, x is going to be equal to the square root okay? You can leave it like that, but that's a bit meaningless if you go into a shop and say, can I have the square root of 2,000 over the amount of fencing? So how much fencing does this guy need? What's it going to be? 25,82, right? I would have made the question of what's the minimum amount of meters he needs to buy, in which case it would be 26 meters. Okay, tough question, but the process is always the same for maximize and minimize questions. Get one variable on its own, which you trying to maximum minimize, and let the derivative be equal to 0. Okay, right. Should we have a 5-minute break, and then I'm going to do the, or let's just do this last question. We're going to do it together quickly now. Okay, right. I'm not going to do the very last question. Right, so just start it while I set up this recording. Okay, and then we'll be done.